So our cable got wrapped around here. Wasn't supposed to, but you get the idea. So I designed this machine. I went to work building it, testing it. It didn't work. So I thought about it. It should work. Turn this around, but put any bit of a load on it, it stops. I'm a bit confused, so I got to thinking about it. So these cables up here are just safety cables. This one and this one. So this isn't attached. And just to show you, this motor runs this, reduction, reduction. Okay. So this T thing is one piece, and then this is two bearings. Okay. So this is going this way, and the idea is that, well, this is close to the center, so it shouldn't slow it down very much. But it does. So the force goes this way, it goes this way, it goes both ways. So any force that goes to the output basically ends up slowing this down. So if you put this ahead of it, like that, then it would pull on it, and it would actually speed it up. But how do you do that? So this, so like that, so this pulls out on it, it goes up, or the speed increases, I mean. Okay? But you see, you don't really want this to move in and out, because it'll lose energy. You don't want it to spin anything but its perfect circle, okay? So I solved the mystery that I didn't understand for a long time, is when you have something sort of like this, when you set this up to go ahead of it, it seems to speed up. Now let me draw this out. So you have your weight going this way, okay, and normally your center is here, so your centrifugal, centripetal is going this way. And then our angle here is 90 degrees. So the way this works is that our direction of the weight is always away from the center a little bit. But the center cannot move. it's stationary. So any force that isn't tangential to the center puts a force on the center. So the center is like a neutral center. It absorbs any force on it. It's sort of like neutral reflective, depending on how you look at it. So the weight moves away from the center. Sorry, it doesn't move away from the center. Its direction is away from the center. It's always 90 degrees. It's always moving away from the center a little bit. So that puts a force this way on the center, and the center absorbs all that force or reflects it because it can't move, so it puts a force back on the weight, causes it to accelerate towards the center. Okay, so the setup that I tried over there with the cables, you have your weight going this way in your center here. Then you have this thing here, close to the center, but you have this force, or we could break it up into this force and this force. So it ends up slowing down. But if we could set it up so that this was ahead of it, then we would have the forces going this way, right? Because they go both ways. You know, you push on something, it pushes back, right? So then we would have this force, this force. So the problem is that you have a wheel like this. Right, so this distance is the same, and this is the same, but if we have something round, so this weight is pulling out. So if we move this thing, like if we move our cable like this, then once we get to here, our cable will be taut. Our weight will have moved down a bit, so we can't move it over to here. So we get it to here, we can't get it to here. So a compromise is to go straight. So we really should be trying to go, so like if this curve is like this, it should be the same curve here. Okay? But straight is close. Okay, now I'm going to demonstrate this so it makes sense to you. And I'll go back to the drawing. Okay, hopefully you can see that. Lighting this time of year is really bad. Let's get this out of the frame. Okay. So you can see, hopefully, this weight moves, but that's just because I stuck it on there. It's not intended to. So we can sort of move this part a bit, okay? So if this is going like this, we can move it forward. We have to do it quickly though. Okay. You can't really see it. It's not going fast enough. Sort of see it there. But the point is that when this goes from here, okay, so this suddenly goes to there, then it pulls itself to speed up. Because there's this phenomenon where that if you take something like this, okay, and you move the center like this, it speeds up. And it doesn't seem to take a lot of effort, but it's hard to make a machine that does this, or I didn't succeed, so I could never measure it, okay? But it's the same thing that I'm talking about, where the centrifugal force actually makes it speed up. So, like I said, this method, see, this comes around like this, okay? And we want to move this to here instantly, because see, it goes out, and once it goes out, you have to put in energy to pull it back in. So let's go back to our drawing board. So our weight, like this, that's at 90 degrees. But if we move this center forwards or backwards, then this will stay the same. But our angle will be different. So we have this going on, this going on. Right, so the reason there's double arrows is that if this is stationary or even hard to move, then it'll put a force on the weight to move it. It kind of takes some thinking, but that's why something spins, is that the weight putting force on the center, and then the center not being able to move, put the force back. So it would actually be like this. If these can't move, right? Center can't move, it's only one way. So if we move our center behind where the weight's going, it'll slow down. And if we move it in front of it, then it'll speed up from the centrifugal force. So, how do we make a machine that does this? Let's try to draw it up here. We have a circle, okay? That's the center. Here's our weight. Well, we can divide our circle into infinite number of sections. 2 is the easiest, of course. So you have a weight where the center can move back and forth, and then the next one that would be easy would be 4. So the way this works is when the weight goes around the circle, and the weight is here, probably have to do it back here. But no, when it's here, but here, there we go. Then we would move it to here. So let's draw that again, make it less confusing. So your pivot is here, so your weight goes around to here, and then you want to slide this here, right? And then so you have it jumping from 4 points. Okay. So I'm going to demonstrate this one more time. Find something to demonstrate it with. Okay, that's basically stationary, but when this gets to here, if I move this like this, somewhere, it's the exact point. You kind of have to go frame by frame to see exactly where. It should be right here. I keep confusing myself. Yeah, there we go. String out of here. So when this gets to here, okay, then we want to jump to here, right? So we really want to make a circle like this, but straight is okay, but we definitely don't want to go like this, because then it will go out, and then we can't pull it back in. So it has to be quick. See that? So that is what you have to do with a weight to get it to spin with free energy. Okay? Now the two-stage oscillator is a little bit simpler. Let me just go over that. So the two-stage oscillator by Milkovic is really simple, is that the centrifugal force, and in this case gravity too, but you don't really get free energy out of gravity, not easily, wants to pull this down, away from the center, right? So we let the center move a little bit, and we lose a little bit of energy, but you can set it up over unity. And the other thing is that it does not have to oscillate. It can spin around like this, right? So you could have it spin around like this, and then it slide one way and then the other, and you can set it up to go smoothly, but then your output is oscillations, and I don't want output as back and forth oscillations. I want output in a circle, so that's so much easier to work with. So again, as this goes around, you have to make something set up so that it pulls on something that's actually ahead of it. So it's better that it's actually stationary, because there's more force goes to speeding up the weight than if it moves. So you really want this to jump. So, like with this, when it gets to here, just beyond, say it's just beyond there, you would move it to here. So it would always be pulling a little bit this way. So it's a long video, probably pretty boring, but it's a lot to take in.